As platform engineers and DevOps, tracking cloud assets can be a real pain, but with CloudQuery and Grafana, building a cloud asset inventory has never been easier. Hi, I'm Tim, and in this series we'll build a cloud asset inventory that will help you keep track of it all. This tutorial looks at gathering data from AWS, so if that's not your cloud, check out one of our other videos in the series. So let's take a quick look at the architecture for this cloud asset inventory. On the left, we've got CloudQuery collecting the asset state from AWS and pushing it to the Postgres database in the middle. On the right, we have Grafana for inspecting that asset database and providing dashboards and alerts. In this case, CloudQuery is being deployed to an EKS cluster where it assumes an IAM role that allows it to read the current state of your AWS assets. So before we can deploy CloudQuery then, we need to define an IAM role for the CloudQuery cron job to assume. The easiest way to do this is via the EKSCTL command, so that's what we'll do here. Okay, so EKSCTL, create, and then IAM service account. Then we're going to give it a name. I'm just going to call it CQ service account because I'm pretty lazy. Then we're going to put in a namespace. This is the Kubernetes namespace, so I'm just going to put it in the CloudQuery namespace. Then we need to tell it which cluster to put this on. So for me, that's extravagant gopher, and then a really long series of numbers. Yeah, hopefully I get this right first time. Right. Then it's the role name. This is just for IAM, so I'm going to call it CQ role. Then we need the ARN. So this is the policy ARN that we're attaching. So for that, I'm just going to use the default AWS read access ARN. You could make something that's a little more locked down if you want, but yeah, I'm just going to use the default read-only one here. CloudQuery is not really going to access anything that could be potentially secret information, so I wouldn't worry about it too much, but you can make a lockdown policy if you want. For me, region EUS 2, and then I'm just going to tell it to approve because I know that this should be correct, so let's go. Now, this is going to take a little while, so I'm just going to speed things up when we go to the actual video here, just to kind of like scrub through it a bit faster, so you don't have to wait. So, next we need to create a secret to contain our Postgres connection string. Okay, so kubectl, create secret, generic. Then we'll give it a name, call it CloudQuery Postgres Secret, I guess. Then we'll put in the namespace CloudQuery, that's where we're doing everything today. And we need to define the literal, so from literal, if I can spell literal correctly. Then it's PG connection str is what we're going to go with here. It's our Postgres connection string. So PostgreSQL : // username's Postgres. Password for this one will be Postgres because it's just a temporary database. Now I just need to look this up on the AWS console. Great. Just paste it in here. There we go, database 1, wonderful, and it's at port 5432 or 5432. and we'll just use the default Postgres database here. To make it easier to deploy CloudQuery on Kubernetes, we've made a Helm chart that helps abstract away all the complexity. To use it, we need to override some default fields. And while we could use individual overrides using the set argument, you probably want to track the values that you're using. So let's create a values override.yaml. Okay, so the first thing I'm going to do is I'm going to disable the admin container. We're not going to do any debugging, or at least I hope not, so I'm just going to disable it because we won't need it. Next thing, I want to bring in the secret that we created earlier. So this is secret ref, and then CloudQuery Postgres secret. And then after that, I'm going to bring in the service account that we created earlier. So here I'm just going to add the service account block, and then the name is going to be CQ service account. And then I'm going to want to hard code the image version that we're using. By default it uses latest, but we want to actually tag this so that we know precisely which version that we're using if we do hit a problem. So that's 3.10 at the moment. And then for the schedule, I'm going to use 00***, which is standard cron tab for midnight every day. But you can set that to whatever you want. And then we're going to add the CloudQuery config. So the kind here is the source for the first file. And then in the spec, we're going to want to make an AWS type file. So we'll just call it AWS. And so we're going to set the path to CloudQuery/AWS, which is where the AWS plugin is. Oh, that's CloudQuery. Yeah. Then I'm just going to set the version for the plugin. That's v22.2.0 is the current one. And now I want to add the tables that we're going to put in. So for this, I'm just going to use star for now, but you could filter this down later if you needed to. And then destination, we're going to set this up to go to PostgreSQL, which we'll do in a minute. And then I'm just going to set up the regions. So this plugin has the support for filtering down the regions. I'm only deploying stuff in EU West 2, so I'll just filter it to that for now. No point pulling everything for every region when I'm only using one region. Okay, so now onto the destination file. So kind is destination. And then in the spec, this time we're going to call it PostgreSQL to line up with the destination that we listed earlier. And then I'm going to set the path for this. It's CloudQuery/PostgreSQL. Yeah. And then I need to set the version again. So this version, latest for Postgres, is v 5.0.2 if memory serves. So then spec, yeah, here we just want to tell it where to find the connection string. We created this connection string earlier, if you remember, and we gave it the environment variable connection_stir. So that matches up with the secret that we created earlier. And yeah, that's the file pretty much done. Okay, so that's our overrides ready. Next thing that we need to do is actually deploy the Helm chart. So to do this, we'll need to set up the Helm repo. Okay, so to do that, we're going to do Helm repo add CloudQuery, and then the URL, so https:// cloudquery.github.io/helm-charts/. Okay, and if like me, you already have it installed, it will say so, and it'll just skip it, so don't worry. Then Helm repo update, just to update the local cache. Okay, so next we want to install it. So Helm install CloudQuery -f, our override file, which is cq overrides.yaml. And then we're going to tell it where to find it. So CloudQuery/CloudQuery. And now we need the namespace. So -n CloudQuery. Now that it's installed, it's given us a little bit of output that tells us some stuff that we can do. So we can trigger the job early by selecting this lot and hitting run. So that's gone and created the job for us automatically, and we can check on the progress of the job, see if it's worked successfully with kubectl logs. Here we just need to edit this to be the job name that was given, which we can see as CloudQuery-cron here. So yeah, run that. We can see that it's migrating, so I'll just Control-C out of that because we don't need to watch it do everything for us. So CloudQuery is up and running and is syncing in the background now. So while that's running, let's go ahead and deploy Grafana so that we can get our dashboards up and running. Similar to CloudQuery, we're going to use the Helm chart here, as this will save us some time when dealing with boilerplate. So let's get into it. Okay, so the first thing I need to do is set up the persistent disk image so that if we import things and the container crashes, we don't have to re-import our dashboards afterwards. So I'll just use a standard PVC here. My defaults for my cluster should pick this up. And then we're going to set up the ingress controller. For the ingress controller, I'm going to use that Nginx controller with Let's Encrypt. But you're probably using ELB or maybe Kong for this. So yeah, just set the cert manager up. I'm going to fast forward through this part because it's not that interesting and highly specific to Nginx. With that done, it's now time to deploy to our Kubernetes. So similar to a CloudQuery, that's going to be Helm repo add, then Grafana, and then the URL. So https://grafana.github.io/helm charts. Helm dash charts, yeah. In this case, again, it already exists. So we'll just sync Helm repo update. And now that's all synced, we can go ahead and install. So Helm install Grafana, then -f Grafana overrides.yaml, because that's how I saved that file. Then we want to tell it where to find it. So Grafana/Grafana, and what namespace to put it in. So again, we'll put this in the CloudQuery namespace. There we go. And yeah, there we go. Installed. Cool. With that installed, we can now inject the prepared SQL View to our Postgres database. This makes it easier to construct certain dashboards than it is via the raw tables that come straight from the AWS source plugin. To download the SQL file, head over to the CloudQuery mono repo, navigate to the AWS source plugin, and you'll find it in a folder called Views. Then load that into your data IDE, I'm using DataGrip here, and run it on the database. Alternatively, you can run it using the PostgreSQL command if you're more comfortable in the terminal. Now we have the view loaded, it's time to head over to Grafana and connect to the database. Okay, so this is fairly straightforward, so I'll fly through, but we go configuration, then data sources, add a data source. It'll put an empty Postgres in, so we're just going to click that. Then I'm going to paste in my RDS URL and add :5432, which is the port number that it's at. In the database, I'm going to put Postgres, which is the same one that we used earlier. Then I'm going to use Postgres as the user, Postgres as the password, and then I'm going to set the SSL mode to require. The last thing I need to do is set the version number to 12+ and save and test, and we're connected. With all the data loaded, the views installed, and our Grafana connected, it's now time to install the dashboards. Okay, so back into the CloudQuery monorepo, we're going plugins, then source, then AWS, then dashboards this time, then Grafana, and now we're going to download this AWS Asset Inventory.json file. I'm going to open that up, hit download, and I'm going to store this in my downloads folder. Then I'm going to hop back to the Grafana dashboard, or interface rather, go new, import, upload JSON file, go to my downloads folder, grab that file we just downloaded, and hit open. I don't feel like I need to change the name or the folder actually, or the UID, so I'm just going to select the PostgreSQL source, which will be the one that we just created. So I'm going to hit import, and then that's going to load our dashboard, and we'll be able to see our assets. It might take a little while for the first view, but here it comes. With some plugins like this one, you might see data from tables that doesn't represent actual resources. In this case, AWS presents things like the available offers for reserved Elasticache nodes with ARNs, making them look like real resources to our SQL View. Since we don't need this data, I can go ahead and add a skip tables element to our source plugin spec. So here I'm just going to add in the problem table. So AWS Elasticache reserved cache nodes offerings. Then VPC endpoint service configuration, then AWS EC2 VPC endpoint services, then AWS EC2 instance types, and lastly AWS EC2 instance statuses. And then just Helm upgrade CloudQuery -f CQ overrides.yaml CloudQuery /CloudQuery -n CloudQuery. And with that, we're done. Welcome to your new Cloud Asset Inventory. From here, you can review what assets are deployed and if you have any unused assets burning a hole through your budget. If you'd like to see more tutorials, demos, and news from us, make sure you subscribe and hit that bell. Thanks for watching and happy querying.